this will be up at the beginning of today's recording, right? And so here are answers. Sort of here's the rest. You can always pause it to look at it. Here's the possible answers. Okay. You have the green outline. On the back of the green outline is the STG, right? It's the graphs from the book, so that you don't have to deface the book. So if there are graphs you need doing on the back of the green sheet, you can write all over those. Keep things nice and clean. Yes. So you walked right by it. Yes. All right. They're up here.
So what's the answer?
There were 3 answers.
Oh, so you don't know which one was.
Wait, I don't want to record this. Solving radical and rational equations algebraically and graphically, it's 20-1 stuff. When solving radical or rational equations, what must you always check for? Restaurants. Still restaurants. Well, up until the R. Then it turned into restrictions. So you got to look for the restrictions, and sometimes we say the non-permissible values. Right? So anytime you look at a radical or rational, the first thing you should do, well, with a radical, the first thing you should do is state the restriction. With a rational, the first thing you should do is factor the denominator, and then use the factored form of the denominator to state the restriction. Right? Especially when we're solving equations. Because when you've stated this restriction, when you go and solve algebraically, you're doing stuff. And the stuff you do can introduce solutions which are not a solution to the original. All right, what's the restriction? X plus 4 has to be, then X has to be. Okay, so if it's under a radical sign, it has to be greater than or equal to 0. If x plus 4 is greater than or equal to 0, then x must be greater than or equal to -4. If we solve this and get an answer below -4, we will reject that, because it would lead to a negative value under the radical sign, and the NHL ref saying you can't do that. Or saying something like get real, because that's imaginary. Okay, what do we do? Algebraically. Step 1. Move the 3 to the other side. Where it becomes what? -3. So it's x minus 3. Now what? It could, but it would get ugly, so let's square both sides. So if that had been like a 2x minus 4, where I could divide by 2 and just end up with a simple thing, I would do that, but it's not. So this is 4 times x plus 4, and this is x squared minus 9. Right? We don't know how to square it by no.
X plus.
Not plus. This is what half of you will do, but the correct answer is
X minus.
Yeah, x squared minus 6x minus 9, right? If you do that, I'll tell you right now, if you square x minus 3 and get x squared minus 9, if question's worth 3 marks, you just lost them all. Okay? Just so everybody understands up front, I will not deduct a half a mark for squaring a binomial and getting 2 terms. I will deduct all the marks for the question. That is an unforgivable error. Okay? You square a binomial, get 2 terms, there is no forgiveness. Yeah, it is. I just left that there. That'd be a half mark if you wrote minus 9, because at least you got 3 terms. The biggest problem with doing that is things go bad, right? And you should know you made a mistake, because even if you're not solving it graphically, you can do it graphically and as a check, which you would do at the end of the test, right? Like do the entire test, then go back and say, I did this algebraically, this is what I think my answers are, let me check. Oh, wow, it's off. What's going on here, right? Okay, so then we just expand and collect, and let's try not to. Okay, so we got x squared minus 10x, anyone? So we get x squared minus 10x minus 7. We do, trust me, it's on my other sheet. It did work. Let me check. Yep, really is that. Which of course does not factor because the only numbers that add just multiply to 7 are 1 and 7, and you can't get a 10 out of a 1 and a 7. So we have to use quadratic formula, right? Now, we'll give you a copy of the formula sheet tomorrow. You have your own copy already, right? You got that orange copy upon which you can make marks and stuff. We'll give you a blank copy, which shall remain blank. We'll give you one of those scan sheets. You can use the back of it for scrap if you like, okay? Because it won't be handed back, but it'll just be stapled onto your multiple choice sheet. And if you use any scrap paper, that will also just get stapled onto that sheet and then held in perpetuity and then put in a box to be shredded at some point. So A is 1, B is negative 10, C is negative 7. So my spidey sense tells me that this has two distinct real roots because I'm going to go minus 4AC, which is minus 4 times 1 times negative 7, which is a plus 28, and the B squared is positive. So I will have a positive number under the radical sign. Then, write this out. Somebody wrote it out on the last test, but they wrote it wrong, so don't do that. Make sure that the division bar extends underneath the whole width of the negative b plus or minus b squared minus 4ac. You may be forgiven once with just a little circle and me extending the line for you, but it needs to be written like this. Plug in. So we've got 10 plus or minus the square root of negative 10 quantity squared. Just remember this is always positive. Okay? Don't square that and get negative 100. It's almost but not quite as bad as squaring a binomial. Make sure that so don't write something that looks like this. Okay? Because really, especially this, that just means do the square root and then multiply it by negative 7. Okay? So extend that out. Over to, all right, what do we got? 10 plus or minus, so we got 128 over 2. And simplify, all right, what's that? 10 plus or minus, it's going to be like 8 root 2 over 2. 8 root 2 over 2. So 5 plus or minus 4 root 2. Yeah, okay, hang on. Oh, look. Yeah, that's right. Oh, except, what's 4 root 2? Well, root 2 is like a little bit over 1, 1.4. 4 times that is like 6. 5 minus 6 would be negative 1. Or what do we say x has to be? Greater than or equal to negative 4. So if we go 5 minus, I think we'll still be okay, right? So even 5, so 5 plus, that's fine. That's going to be positive. 5 minus 4 root 2, that's still above negative 4, but you might want to just verify that. But root 2 is under 2. So if root 2 was 2, that would be 5 minus 8, which is negative 3. So you're fine. Because that's greater than negative 4. Okay. So now, yeah, okay, we've got our solutions, right? Graphically. When you're doing a graphical solution, you require 4 things. So graphical solution. Graphically. Number 1, I need the equation or equations, right? So equation or equations that you're graphing. So like y1 equals, and if perhaps y2 equals, maybe. I need the window. I need a sketch. So the window is of the form x, colon, and then an ordered triple. And y, colon, and then an ordered triple. Need a sketch and an explanation. Explanation could be as simple as I am finding the x coordinates of the point of intersection, or I'm finding the x-intercepts. Okay. So either one, but you got to state which, right? So I'm finding the x coordinates. Don't just say I'm finding the points of intersection. That's not quite good enough, right? Because you're not. You're finding the x coordinate of the point of intersection, or you're finding the x-intercept. Okay, I want to solve this graphically, so I'm going to graph the following: 2 root x plus 4 plus 3 minus x. Okay, so I'm basically just moving that over. I'm going to graph y2 equals 0. I'm okay if you don't say that and then you just say I'm finding the x-intercept. I just do that because it's a bit easier to find. Now I have a problem. I put one of the more complicated questions into the graphing calculator, and if I pull this up, I'll have to destroy it. So, all right, so you're just going to have to graph this yourself.
So when you say, like, on a test, we have to put those on the sketch, the graph, you have to label all of them?
Not really. No, like if there's an intersection, you could just sort of circle it, right? And then just say I'm finding the x coordinates of the points of intersection. You got circled on the graph above or something. Okay, so if we sketch this, what does it look? Oh, first of all, we need a window. So, okay, you know that x has to be greater than -4, right? So let's x. Let's go from -5. Now you're going to find out that you have to go past 10. So I'm going to 15 by 1s. And my y's go from, let's just do it. Oh, I hate this calculator. All right, I'm just going to kill this calculator and restart it. Come on. Okay, so there's my graph. This is in the standard window, so I can see that, yeah, I need to be looking over here because I'm looking for the x-intercept. So I'm going to move that out a bit. And I don't really have to go that low on this. Again, I'm just looking for the x-intercept. So I'm going to readjust my window. So -5 to 15 should show me that. And a scale of 1. And let's say -2 to 10 with a scale of 1. And hit graph. Okay, sketch the graph. So it looks like this. Okay, that's kind of interesting because I'm only seeing one x-intercept, and I thought maybe we had 2 solutions, right? What was the other? It was 5 minus 4 root 2. So I'm going to work that out. 5 minus 4 root 2.
It's like
-0.6. So why am I not seeing? That would be here. Yeah, what's going on?
So I grabbed the quadratic product, x squared minus 10x minus 7.
Yeah. Yeah, so then why is it a solution to the original but not? Oh, so here's the deal. So what happened? So 5 minus 4 root 2 is a negative number. Root x plus 4 has to be what? Got to be positive. Multiply it by 2, it's still positive. Add 3 to it, it's still positive. So there cannot be, this can't be a negative. When we squared both sides, we allowed ourselves to introduce a negative solution. So now we go back down here and say, wait, it's not that. It's just x, whoops, x is equal to 5 plus 4 root 2. So a negative solution is inadmissible because the right-hand side of this equation, the left-hand side has to be positive, so the right-hand side, the x value, can't be negative. That's why, see, it's a good thing we did a graphical to check it, because it allowed us to say, oh yeah, wait, even though that wasn't less than -4, it's still not an admissible solution.
so if we didn't graph it, we wouldn't.
You didn't graph it and you put both answers in, you lose a half mark for giving me an
So
answer.
how would you
that
check
isn't-
it algebraically?
Well, what I just did. You'd say, if my answer, you just say, look, root of x plus 4 is a positive. Square root is always positive. Times 2 is positive, plus 3 is positive. This must be a positive number at least greater than 3. Right? Like my solution is going to be 3 or bigger. Right? Because if that's 0, that's still 3.
Yeah.
So if my solution is less than 3 and I had an x value that was less than 3, then that's not allowed.
Oh,
Okay? So I can't have a negative x because this must be positive, so that has to be positive.
So your x plus 4 is bigger than or equal to 0 is wrong. Right?
Well, no, x still has to be, like, that's part of it, but it's not a solution. Okay. My restriction is, like, there's nothing here. This is the x is negative 4. That graphs the thing okay, but we're looking for the intercept, and there's only this one. Okay, and then here we are going to say what? Find the x-intercept. Find x-intercept. Oh, which I guess I should do. So I'm going to go to y equals. I like to graph y2 as 0, and I really like the color calculator. And then I'm just going to find, instead of doing the zeros thing, which I don't like doing, I'm going to find the intersect. Whether you do zeros or intersect doesn't matter. And we get 10.66. So x is equal to 10.66. And if I went back to the calculator and quit and brought this back down and said plus instead of minus, then I get 10.66, right, rounded. So, whoa, so we got to watch out for stuff, right? We square both sides of a radical, we can introduce solutions, extraneous solutions, right? And we need to reject them. So we needed to look a little bit closer at the 5 minus 4 root 2. Okay, and graphical helps you out then, right, by verifying graphically? Yeah.
Do we have to, like, if we do find an extraneous solution, do you want us to write it out somewhere?
You can write it out, and then, so just do this, and then sort of cross that off, just indicate, look. So it's like, look, here's both of my solutions, but I can't use the negative one.
Okay.
Okay, and you could just say, since x must be positive or something.
Okay.
So yeah, show me the solution and then reject it, right? Just say, this is the solution I got, but this is not allowed under this circumstance. Okay, so you guys try this one. I'm just going to back up through the screens for a second for the benefit of the one. We picked a lousy day to miss. Day I didn't record stuff. All right, here's the first page. Scrolling through slowly. Here's the second page. Alright, that's all there is to it. If you weren't here, here's the third page. Alright, and now graphing. So there's the graph. That's -2, that's 7. You can see it. You can also get it out of the table. So you can see at 7 it's a 0. At 0 it's an error, right? We know we can't do 0. And at -2, this is also 0. All right, so graphically, you got to say, what am I graphing? So y1 is equal to 14 over x minus x plus 5. I'm going to do y2 is 0. You don't need to write that in. Right, because you could just say I'm finding the x-intercepts. I need a window. What was the window? Yeah, -10 to 10 is fine. -10 to 10 by 1s. Just saying it'll take less time to upload. There's the graph, so we're going to draw a sketch of the graph. Okay, that's 7, that's -2. You could label that if you want. What else? Oh, we say find the x-intercept. And x is equal to -2 or 7. Okay? And one last thing at the bottom. the roots of the equation are blank the x-intercepts of the function. So the roots of the equation are the same as?
Equal,
I'm going to go with the same as.
but it's one space, so it's implying one word.
You still have to say equal to. You can't say are equal the.
I guess.
So the same as.
This is math, not English.
Equal to.
There we go.
I know it's not English, but you still have to try and use proper English. Okay. You try this. I'll pause this. You remind me to unpause this when I do something useful. Okay, so I'm going to show you how I do this, and so my lowest common denominator is x minus 1 times x plus 5. So I need to multiply each term by the designated leave early, right? There's always one of you coming up soon. I gotta leave early. So I need to multiply each term by x minus 1, x plus 5. There's a way to do that which is very long, which is to show each term. And then there's this, which is to say, okay, so the 3 doesn't have anything on the bottom to cancel. Let's go do that. Minus 2x. The 2x already has an x minus 1. So it needs an x plus 5, and the 1 has both, so it'll just be a 1. Okay, so I have now multiplied all 3 terms by x minus 1 times x plus 5. Now I get to expand this. Okay, so we need to make a quadratic equation, something that's equal to 0. I'm on the wrong page. So I'm just going to do that kind of one step at a time. I'm going to say I need the 3, and it's going to multiply this, which is x squared plus 5 minus 1, so plus 4x minus 5, minus 2x squared minus 10x. I'm going to say minus 1 equals 0.
What happened to the denominator?
I don't know, man. The first time I did this, I lost the x on the 10, and it just, wow, it really went ugly. I got rid of them. Go back and look at your notes from 20-1 on solving. There's a way to do it where you show a lot more work. This is not showing much work. Okay? So I would expect you to get to that line, but maybe some of you will take 2 more lines to get there. Okay? I'm not going through it, but you can go through your old notes. And come see me, and we'll go through it in detail if you want to. But this is a skill you supposedly have now, right? One you've been carrying with you. It's dormant right now. It'll come back to you. Okay, so now I can collect the terms. So I've got an x squared plus 2x minus 16 is equal to 0. So of course, the Saunders e-bike. They actually started a campaign on Kickstarter for another one, but they're not shipping to Canada. They're not doing any international shipping. So that's a pain. But I like my bike, it's fine. So A is 1, B is 2, C is negative 16. The fact that C is negative tells me there are 2 real distinct roots, right? Because B squared minus 4AC will have to be positive. The formula, read it off the formula sheet. Okay, so that no point in getting this far and getting something wrong because you memorized the formula wrong. So I got negative 2 plus or minus, I've got 4 plus 64, which is 68. So root 68 over 2. Root 68 is 2 root 17 over 2. So x is equal to negative 1 plus or minus root 17. Now, did I do any restrictions? Yeah, so it's not a 1, though neither of those numbers are 1 or negative 5. Okay, I didn't square both sides, so I haven't introduced an answer which is positive that was negative. Right, so there should be 2 solutions here. Okay, so other than maybe getting this line, everybody okay with what happened beneath? So you're just pounding through piled up, right? So, if you do this and then you go graphically and you realize my answer's wrong, if there's not much time left, then just leave it. You can just make a little note somewhere in there. There's a mistake. We'll find it later, but you still may have picked up most of the marks, right? Because it's process, right? I'm going through the steps. Did you go through the steps? And if you only made one mistake, you're going to lose like a half a mark, unless it was squaring a binomial and getting 2 terms, and it's just gone at that point. If you make a mistake that turns it into a very easy question, and you're thinking, wow, how is this worth 3 marks? Because it only took me a line, you're going to lose most of the marks. Okay, like you have to at least provide yourself the opportunity to make more mistakes, and you can't just make a mistake that simplifies it to the point where, look, it's x equals 2. It took 1 line to do. No, sorry. Okay. Graphical. You have 2 choices. I have plotted this. And let's see. Here it is as 2 separate graphs, right? So you'd graph this is y1 and this one is y2. Okay, and you can see there's 2 answers, here and here. You can see the graphs very nicely. They will not look that nice on a TI-80. On an 84 color, they'll look pretty close to that, right? Look pretty close, right? What does it do? It does something. Yeah, it just, what it does, doesn't really show you this that well, right? But you can still see it. Does anybody have an 83 or 83 plus?
Yeah, here.
Okay, so if you're not here, I'll see you in wise time, because there ain't no way you're getting anything out of this recording. And if you're just some random person watching this just wasn't a good one, I'm sorry. Don't make bad comments about it. Don't unsubscribe. There's like 130 people subscribe to my channel. What's up with that? And they're none of you. Right? Okay, so here's algebraically. Graphically, we do not want to get this, which is the result of graphing y1 and y2. Okay, graph, not easy to see, right? You can't tell. Well, you can tell there's something here. You have no idea there's something here, I don't think. So graphically do this. 3 minus 2x over x minus 1 minus 1 over x squared plus 4x minus 5. Okay, you're going to graph that. I graph also y2 equals 0. You don't need to put that in because you're just saying I'm finding the x-intercepts. Okay, you set your window accordingly. I think negative 10 to 10 will do. Okay, you find the x-intercepts. You round accordingly. Now, if you're doing it algebraically, we're pretty much asking for exact values, in which case thou shalt not work it out, right? Thou shalt leave it as a simplified. It's got to be simplified. You can't leave this as a root 68. You can't leave this as a 2 root 17. Right? You have to simplify it down. Let's go to this guy. Yep. All right, what do we got? 3 minus, I'm going to throw brackets around this just because I like to throw brackets around stuff. 2x divided by x minus 1. Close that. Minus 1 divided by bracket x squared minus 4x minus 5. Okay, graph. Wow, okay. I did not graph whatever it was I was supposed to be graphing. 3 minus 2x minus 1 minus... Oh, it's x squared plus 4x. Okay, plus 4x. X squared. Come on. Plus. Math. So I could see there's something, probably something here and here. So second calc. I'm doing intersects because I'm intersecting with the blue line, red line. Okay, wait, gotta go along here, right to about there. 1, 2, 3. So x equals negative 5.12. Okay, so let's just check that. If we quit out of this, I want negative 1 minus root 17. Messed up there. Minus. That'll work. Negative 5.12. Okay, so it works. And the other one then, similarly, you'll get the positive 3 point whatever. Last, oh wow, last one.
I don't think we'll have enough time.
I know if I gave you the time to work on it, we would not have enough time. Yeah, this would take a while. All right, so let's just do this one together as best we can. I'll do the algebraic, you can do the graphical, right? So for graphically, you're going to move these guys over, right? So you're going to go this, plus this. Okay, so we'll just do algebraically. Step 1, factor all denominators. State restrictions. 3, 4, 3, 4. So just 3 and 4. Your lowest common denominator. You need a 2, and you need an x minus 3, and you need an x minus 4. Okay, that's all I need. So when you're doing common denominator, just say, is there a 2? Yep. Is there an x minus 3? Is there an x minus 4? I don't need another x minus 3. Just one will do. The idea now is I'm going to multiply each of these 4 terms by this denominator. When I do that, the first term is going to take out these 2 guys, and all that will be left is x minus 4. So on the first term, I'm going to end up with x plus 1 times x minus 4. On the second term, I've got x plus 1. So I got an x minus 4. So I got a 2 times x minus 3. Let's just write that as 2x minus 6, right? 2x minus 6 equals, that has an x minus 3, so I don't need it, but I do need a 2 times x minus 4, so let's call that 1 times 2x minus 8. I'll just multiply the 2 in. Minus, this has a 2 and an x minus 4, so I only need the x minus 3, so I have 3x minus 2 times x minus 3. Now, whatever method you use, eventually you end up with a line that looks something like this. Then you expand. So we have x squared minus 3x minus 4 minus 2x squared minus 6x plus 2 minus 4x minus 6. So I'll deal with that minus later. I don't want to do them both at once because I'll mess up if I haven't already. And I got 2x minus 8. Minus, and again, I'll do the same thing here. So 3x squared minus 9 minus 2 is minus 11x plus 6. Next line I'm going to go through. Now I'm going to remove. Okay, I'm recording. It's amazing. First time today. I'm going to remove the minus signs. So x squared minus 3x minus 4 minus 2x squared plus 4x plus 6 is equal to 2x minus 8 minus 3x squared plus 11x minus 6. I'm going to simplify the left side and the right side. So I get negative x squared plus x plus 2 is equal to negative 3x squared plus 13x minus 14. I'm going to move these guys over there. So I'm going to add 3x squared, giving me 2x squared. I'm going to subtract, so that'll be minus 12x, and I'm going to add plus 16 is equal to 0. I'm going to look at my sheet and say, yeah, it's actually right. The sheet has lots of erasing on it from mistakes made while I was doing this. I can now divide out the 2. Right, so I just divide both sides by 2. It's actually a different graph, but it has the same x-intercepts, which is what matters. Miraculously enough, this actually does factor. So then we say x equals 4, and we say x equals 2. Then we go look at our restrictions, and the restrictions say that x cannot be 4. So then we take this out. And we say there is one answer, and that answer is x equals 2. We would check that by graphing. We will graph by moving everything to one side, because otherwise you're looking at a very complicated graph. And then looking for the x-intercepts, which we know should happen at 2. Yeah? What? Right there? That covers it all up. All right, so the graphical is left for you. Now, what are you going to do this weekend? You're going to do inverses and polynomials. You're not going to worry about this stuff until Monday night, because it's not on the test. You're going to worry about stuff. You're going to find that online quiz. You're going to do the online quiz, right? Well, print it off. Do it like a quiz, right? Like, don't sit down with your book and do it. Do some studying, then sit down. Give yourself 90 minutes. Do it. Print off the answers. Check your answers. Okay? All you can do is come in Monday morning and say, hey, how do I do this?